Okay, welcome back. Now we're going to do an example. And in this example, we're going to use the intermediate value theorem to show that there is a zero, that there is at least one zero for this given function. Okay, so what they want to do is show that this function has at least one zero. Okay, so how do we do that? Well, we're going to use the intermediate value theorem to show that there is a zero for this function by saying, hey, remember what a zero is. A zero is where this function is equal to zero. Or in other words, where does this function cross the x-axis? Okay, so in other words, we're looking for the x value where this function is equal to zero. And so how are we going to do that? Well, since we want to use the intermediate value theorem, we could use the fact that this is continuous, right? So this is continuous everywhere. This function is continuous everywhere in the number line, all real numbers. So what we could do is we could find a value, an interval where f of a is one sign, positive or negative, and f of b is the opposite sign. Because that would mean, right, that would mean we have something like this, where we have something maybe like this, where over here it's positive, and over here it's negative, which means if it's continuous, there has to be a point in between those two where it crosses at zero, right? So that's how powerful the intermediate value theorem is we can use it to find zeros, or we can find intervals where there's at least one zero. Okay? So let's do that. All right, so since we already know that this is continuous everywhere, we just need to find an a value where f of a, and we have to find an a, so basically we have to find an interval a comma b such that f of a and f of b have opposite signs. Oops. Okay. Well, how do we do that? Well, we just have to kind of look at the function and pick some good numbers where f of a and f of b are going to have opposite signs. Okay? So let's just pick some points. Some easy ones to deal with, right? Well, let's use 0. 0 is always an easy one. So if we use f of 0, what do we get? F of 0 gives us 0 minus cosine 0, which equals negative 1. Okay, so now that's negative. Now all we need is a value of x that's going to give us something positive. Well, we could, here, pi over 2. Okay, because pi over 2, cosine is going to be 0 at pi over 2. So let's use pi over 2 because that makes it really easy. So let's do f of pi over 2. And that's going to give us pi over 2 minus 0 because cosine of pi over 2 is 0. So that makes it easy. So this is going to be pi over 2. That is obviously positive. So guess what? Now we've got our interval. So our interval is going to go from 0 to pi over 2. And so since this is continuous on this bounded closed interval, we know by the intermediate value theorem, there must exist a real number C in the interval 0 to pi over 2 such that f of C is equal to 0. And that's how you use the intermediate value theorem to prove that there exists at least one zero. Now, the thing is there might be more than one zero in this interval, okay? The only thing that intermediate value theorem can tell us is that there is at least one zero, okay? It might be more than one, but that's what they asked. They wanted to show that there was at least one zero for this function, and we did that. All right. Have a great day.